NMOS. Now I want to spend some time to talk about the small signal circuit for the PMOS. And it is very easy. On the top right is the small signal model I just gave you for NMOS, but I flip it. Just look at this. Source, right? And then you have drain, have this current going down, and you have this resistor, right? This is the same. Source, you have drain, current going to the source, resistor, and then the gate. Do you agree? This is just a flipping, right? All you need to do just rotate your computer, your notebook, then you will see it is the same, right? Why I want to say that? I want to say that turn out the PMOS is exactly the same as the NMOS. Whether you call it flip or not, it doesn't matter. But I show you this is the small signal for the PMOS. This is the gate. This is the drain. This is the source. Isn't that they have exactly the same topology? But most importantly is the definition of the plus minus. This is VGS. This point minus this point, VGS. This is the current where it is going. This is, although we call it V1, right? So this is just VGS. And okay. I have a question for you. Where should be the source of PMOS? Is it a higher potential or lower potential? Higher potential. Why it is grounded and I call it source? Just because maybe this is negative, but it is not. Because this is a very good. Because this is a small signal. This is actually the VDD. Okay? So let's take a look what it means by having the positive voltage or whatever, right? So let's look at this. VDD, VG, and then you have IDS. This is normal to you, right? This is a PMOS, correct? What if, for example, let's say this is equal to 5 volts, apply this to 4 volts, fine, then I have 1 milliampere going down. Everything normal, right? Current go from 5 volt, 1 milliampere going down. This is 4 volt because PMOS, you need to have a negative VGS to turn it on. Need to be more negative than the VTH, okay? Now, so let me write this. So I have 1 milliampere going down, right? Now, what if I change this to 4 point, let me use another direction. Yeah, 4.1 volt. Should I get more current or less current? Less. Because you have a small difference in VGS, right? Do you guys agree? Right? For example, if this becomes 5 volt, you turn this off, right? You just don't have VGS. Right? Or it becomes the VTH. So how much current do I get? You say less. Maybe 0.99 ampere. Make sense? This is the total current. But I can treat this as what? I can say, hey, this is still have 1 milliampere of DC current going down, but I have 0.01 milliampere of the AC current going up. This plus this equal to 0.99. Do you agree? So this is exactly equals to VGS equals to 0.1 volt. Right? VGS equals to 0.1 volt for small signal model. But with IDS equals to 0.01 milliampere. It's just that it's the same as before, the DC. We are still at 4 volts. You still have 1 milliampere going down. But now I apply a VGS, which is positive. Then you push the current up. You add a current going up, which looks weird. You have current going from ground to the VDD. But no, this is just the relative, right? So that is the meaning here. When this is 0.1 volt, VGS, right? Or we call this VY, right? Equal to 0.1 volt. What does it mean? It means that I have a less difference between the source and the gate. And what happened? It brings 0.01 milliampere up, which means the total current going down is less, right? So that is the meaning of the small signal. So from here, you see that it doesn't matter to have negative voltage. It also doesn't matter to have negative current in small signal, because it's just talking about compared to your DC, whether I increase or reduce it when you apply a small signal. Is this clear for this slide? Okay, I hope you can appreciate, but really think about what I'm talking about, right? With that.